Hi again. So we were able to take a look at different tables, but now we're going to compare relationships using equations. We want to be able to take a look at certain equations and decide whether or not this relationship will be proportional or not proportional. To do so today, we're going to take a look at different conversions. We are going to use this equation to change temperatures from Celsius to Fahrenheit. So the equation F, Fahrenheit, is equal to 9/5 times C, or the temperature in Celsius, plus 32. Now, in order to solve for Fahrenheit, wherever I see C, I'm going to plug in my first value, which is 20. Go ahead and try that on your own now by pausing the video. Awesome, so if your first step was to multiply 9/5 times 20, then you're great. 9/5 times 20 is going to give me 36. Remember, when I have a whole number times a fraction, I can just make that whole number a fraction as well by putting it over 1. 20 divided by 1 is 20 itself. So I'm going to just multiply across normally. 9 times 20 is equal to 180, and 5 times 1 is equal to 5. What I can do here is just reduce this fraction. To reduce that fraction, I'm going to divide 180 by 5. 5 goes into 18 3 times. 3 times 5 is equal to 15. 18 minus 15 is equal to 3. And 5 goes into 30 6 times. We have an even answer. So I'm done with that first part of the equation. 9/5 times 20 is equal to 36, and then 36 plus 32. I can just do this on the side right over here. 68. Which means that 20 degrees in Celsius is equal to 68 degrees in Fahrenheit. If you've ever been to Australia, or if you ever go anywhere where they're using Celsius, if someone says that it's 20 degrees Celsius, it means that it's pretty warm, right? It's 68 degrees Fahrenheit. Go ahead and try the same thing for the next two rows. Wherever you see a C, you are going to plug in 4 first, and then whenever you see a C, once you finish that, you're going to plug in 175 for C. And your finished table should look a little something like this. Now, we're going to keep that table in our reminder, and we're just going to move it to the side. Let's focus on question number 2, which asks us to use the equation C equals 2.54 n. C is going to represent the length in centimeters, and n is going to represent the length in inches. So now we're going to be converting from inches to centimeters. So I'm going to move that to the side, and I'm going to draw out my equation now. I have C is equal to 2.54 times 10, because that was my first length in inches. If you have a calculator, you can go ahead and plug that in now. If you solved and found 25 4/10, then you are good to go. Go ahead and try the next two rows. Your finished table should look a little something like this. Now that we have our two tables completely filled out, let's take a look at our two equations and begin to compare them. What do you notice? In my first equation, I'm adding a value. I'm adding that value of 32. In my second equation, right over here, I'm not adding anything at all. By looking at the data in our tables and by comparing our equations, do you think that the relationship between temperature in Celsius and temperature in Fahrenheit is proportional? Do you think that the length in inches is proportional to the length in centimeters? Are they both proportional, only one of them, or neither? So the conversion in temperature, right over here, is not going to be proportional. The number of degrees Fahrenheit per degree Celsius is not the same. Versus when we look over here at the conversion between inches and centimeters, it is the same. The number of centimeters per inch is 2.5. It is the same. If we look over here at our Fahrenheit equation, it is not the same because we add that value of 32. What do we notice about the forms of these equations? Yeah, in a proportional relationship, we are just multiplying. We're not adding, dividing, subtracting anything. Proportional relationships are characterized by equations of the form y equals kx, which means that the equations for proportional relationships are always going to look really similar to this equation. Our variables might change, but you are always going to have your constant of proportionality, which is k, multiplied by one of the variables. So whenever we're looking at certain equations, if they do not look similar to this one, then it probably means it's not a proportional relationship. Let's take a look at these 4 extra equations that I've just added in. Which of these 4, what colors represent proportional relationships and which ones do not? Pause the video and write down your answer. Y equals 3x is going to be a proportional relationship. It follows that same model of our proportional relationship form. Y equals 7x minus 2 is not going to be a proportional relationship. Our variable is not going to grow by the same amount each time. Z equals 5p, yes, although my variables are different, my constant of proportionality is still going to be multiplied by that one variable. Y equals 4x plus 4 is not going to be proportional for the same reason that this orange one was not. So remember, y'all, when we're looking at proportional relationships and their equations, we want to make sure that they follow this same format. The variables might change, our constant of proportionality might change, but everything else is going to want to stay the same.